Welcome to another video and episode on my Raspberry Pi 2 running Ubuntu Linux with robot operating system. Connected by a serial Pi Plus to a serial cable which ends on a laptop with a Minicom serial terminal. Hidden is a network cable for VNC, and this is a band cable which is connected to the GPIO, general purpose input output, connected to this breadboard with some electronics and fischertechnik electronics. A motor which should be connected. Let me do that right now. Which is also fischertechnik and pulse width modulated. A photo resistor, photo transistor, actually not a resistor, and an LED with two normal LEDs, a push button, all remaining from let's say a previous experiment. Last time I used the Bash scripting language to gain access to the GPIO, and I got these LEDs, this one, and the motor to work, in the sense that the motor just does something like this, and that's it. However, there's something wrong again. Last time I had a severe problem booting the Raspberry Pi 2, and that problem is now seemingly again. White and red. Red is power, white is the SD card, which is, well, the hard disk on which Ubuntu is realized. After rebooting, which is actually pull and plug of a USB cable, it didn't work. What did work was pulling the plug, replacing or ejecting and replacing the SD card, and then powering up, which did work. And looking at the time that I started Minicom, which is about half an hour ago, and in half an hour nothing has happened. So I am doing now exactly the same. Pull the plug, lights go off, and now the intention is to eject the card and insert the card, and push the plug again. And now, surprisingly, it works. I do not see the yellow LED, but on the terminal, the serial terminal, I can see that things do work. Kind of. Because the last line for now is reading initrd.image. Now things come. So maybe I was too quick in my analysis that it doesn't work anymore. But this is a fake sign. And oh, that's even worse. Oh yeah, it does work. So the sign is here that I should back up this SD card as quickly as possible and provide me with another one that may work, because this may be the end of this card. It has given me problems before, but now this is too scary to go on for a long time. So let's then see whatever may go. So now the boot sequence has succeeded. It runs again, albeit a bit slowly, and I started the VNC server and had to restart it because I found that on the third one, which is special now for a tablet, I used the wrong geometry. So right now the geometry is exactly what you would expect. Full covered in the whole display. Will it work? We shall see. Because also well, there's the bash story again, but let me go back to the first thing. Here I started the whole thing first hand, then taking a break and coming back half an hour later. Nothing had happened, it was all black. Pulling the plug and reseating the SD card gave me this whole output, which looks good. Starting VNC manually, and here it still was the wrong configuration, which I found out once I looked at the tablet, and now it's alright. Will it do alright? Well, the only thing I can do is once again starting this here, bash GPIO text, then LED should run, this one should run, and this one should jolt, and hopefully this LED as well. Permission denied. Why will that be? Because I don't do sudo. Hold on. So how did I do it? No, it is bash. I am using bash. Just bash. This is not nice. And now I'm going to the tablet. I'll show you the tablet. Opening terminal. Because of the keyboard I have to scroll it up. So now I am right here. Yeah, this is exactly what I did last time. So there's no difference in there. But let me just use it. Let's see. Does it do exactly the same thing? No, it doesn't. So here on the terminal I don't get that specific permission denied error. Just device or resource busy. So let's go back here and see whatever happens. When I do this, now it's the same. Okay. I see one LED. What else do I see? Hold on. There's more to see. There's got to be. Why do I only see one LED? There's one wire on the loose, but that's not a problem right now. Although I should fix it, I know. Oh wait, there's one wire gone here, and there's a wire gone there. That's not good. That explains a lot. Not quite sure where this wire should go exactly. I have to find that out. So let me go start GIDA, the editor, circuit editor, and find out where exactly everything should be, and then test again. So this is the schematics again, with red LED into pin 18. There are some wires on loose, and those are non-critical wires, like from the voltage divider, from the phototransistor, but the motor should be working, which is right here on 32. So let's try again. Oh wait, I'm in the wrong window. I should be here. And that would be nice if I had a look at the motor as well. So try again. Well, that's one improvement. The fischertechnik LED worked, but there's no sign of the red LED. It should be in 18, 2, 4, 6, 8, 10, 12, 14, 16, 18, yes. So theoretically it should work. And yes, it is indeed theory. Yep, okay, that's wiring. And last but not least, the motor. That doesn't do anything, but the GPIO does work. Alright, that's a good thing. Then it is really time to open up the rest of the stuff, because it's about ROS. Going to Catkin, source, development, setup, bash. Oh, and of course a tab for ROS core to run. Without this nothing works. Well, nothing of ROS works. Alright. So happy that that works again. And these were, yes, I was looking for this one. Now that's one, and this is one. This is the publisher, of which I disabled the entire GPIO class. However, now I have to check one thing. My server is not mounted. Okay, but I checked on this, and it turns out that everything I do here is correct. So going to this line and here, this should work. There's no thing against it. The only thing that could be against it, no, because GPIO class is right here. It is right here. And last time with the very big crash that I had to rebuild the control. So actually this is control, then let's start and see if this still runs. Yes. Yes, okay, those two run, fortunately. But, a very big but. Let's go here. Source. No, I do it different. I need to be one here and new tab. Source, development, and setup again, because I'm once again opening a new terminal, and then I say cat can make, because I edited this and enabled it, and this should be working, period. End of discussion, at least again in theory. No, here. Yeah, so where does it go wrong exactly? Where does it start to go wrong? Yep, undefined reference. Okay. So let me go here. Let me check. I have no mount point. I do have a mount point, but because I have this and there's that one in. But this command shows a lot, except for the fact that my server isn't mounted. A lot is mounted, but not my server. So let's do that. And I mounted my server and opened, well, in view mode, the source where I got this from. So this is all the same. Well, not all the same, but most of. And the namespace is the same by now. And I'm going into the main. And yes, this is now ROS, but that doesn't matter. What does matter is that I'm instantiating the GPIO class. and that is the same, doing nothing but that. So why does this work? Because I tested it again. Why does this do work and why does this not do work? Is it because it is a different Raspberry? Because this in the terminal is running on a Raspberry Pi 1, and this is Raspberry Pi 2. But it doesn't say so. It says undefined reference to GPIO class. And that's not possible. Well, you know what I'm going to do? I am going to remove this line and type it again. Include double quote GPIO CLASS.h double quote. Nothing wrong with that, you'd say. And this is what I most of the time copied. Yeah, and if you copy a problem, then yeah, you do copy a problem. But it's not the case in this time here. So let's do it again. Nope. And this gives me a big problem, because this means that no matter how simple this is, without this part of the code, it is impossible to use ROS in C++ on a Raspberry Pi controlling whatever. So whatever the reason may be, I don't know, but the don't run. That much is clear. And this is not making it any easier. So this is once again an episode with its problems. Booting, wiring according to the schematics, and GPIO class again. Yikes. And then a clue comes up, and it points into a very different direction than I anticipated and then I thought. And the clue is this one. CXX11. Apparently Ubuntu version that I use has been equipped with the GNU C++11 compiler. And since the Raspberry Pi 1 is equipped with an older operating system, it will compile differently. Ouch. So let me check. Okay, let me check this one. No input files. How do I find out? Okay. Version 5. Okay, wait, this is GCC. Now I need ++. -v for version or -help, whatever. No, v. Okay. So it is a little narrow, which is correct. Should be. And I'm not finding a version 11. So this is not as simple as I thought, unfortunately. But it is a clue, and I know it works, but I have to find out how. Because apparently something with this, with those quotes, are preventing me from using anything like this. I can try one more thing. And no, not a clue if that will actually work, but who knows. I don't think it will, but so the answer is no. Although the error is different. Now it's not a C11, but now I have a string. Oh wait, here. Yeah, it is the same. Okay, end of story for this time. Need to find out how, why, and etc. Unfortunately. Let's go here and see if I ruined anything. So, start. Oh, right. So, before I do anything else, this is one. In the end, this one. Okay. No, I have to be here. Cat can make. Strange that such a thing actually completely ruins an executable, which should run now. Yes. Then going back here, running, yes, thank you, and then at the same time saying okay, I need the GPIO to work. Yes, thank you. No motor activity though, but so be it. So with the SD card of the Raspberry Pi 2 temporarily running again, at least temporarily, right now. This is kind of working via bash. this is working also, and that's about it. So for now, thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion, and you can also follow me by via Instagram and Twitter. Please show your support, show your appreciation by making a small donation via PayPal or Wired. You can also become a patron and have your name mentioned. More information on my website. You can find everything under this video, and this is going to be continued. Thanks for watching. To be continued.